Today we're doing section 3.4. We want to review using similar triangles. This is a topic that we've talked about in previous units and previous lessons, and we did spend time yesterday reviewing what we already know about similar triangles. But today we want to add in how to determine whether or not triangles are similar just by looking at the angles. And we want to put a little bit of extra practice into something called indirect measurement, which is using similar triangles to determine the measure of things that we can't measure, by taking a yardstick or a ruler too. So, using similar triangles. First we can review, this is what we did yesterday and what we've done in previous units. These instructions tell us these triangles are similar. If these triangles are similar, I don't have to find out that they are. The instructions told me. But if they are similar, then I can use that fact of similarity to determine the measurements of missing sides, right? This side has a missing measurement, but I can go ahead and determine it because I know that these triangles are similar. So as we reviewed, similar triangles, their sides, the ratio of the sides of one triangle to the other form a proportion. So I can pick which one I want on the top, and I'm going to pick this triangle, the small one, to go on the top because that's where x is, and I like to have my x on the top. So the first side ratio is 5/10. So I can go ahead and simplify to 1/2. So 5/10 equals 1/2. And I know that that ratio of the 5/10 or 1/2 has to equal the ratio of this other side, or x/4. Once I have this set up, I've solved 100 of these problems. I know how to do that, no problem. X must equal 2. I know these triangles are similar because the instructions tell me so. And so I can use that fact to set up a proportion using same sides of the triangles, and then I can solve it for the missing side. If I look at number 2, though, it's a little bit more tricky. The first thing I did was I looked and I said, oh, 12/12, they're the same. But they're not, right? If you look, here's the most narrow angle. The most narrow angle on this one's here, right? So actually what I have to do is I kind of have to turn this guy upside down to make them match, right? So this side actually matches with this side. Now the shapes are the same and I can tell which sides go together. These numbers are upside down, so I don't know if you want to leave it this way or if you want to turn it back up. But actually the sides that match are this 12 to the 9. This time I'm putting the big one on top. And the reason why, again, I always want to have my x on the top. I don't have to. I want to go the easiest possible way, and keeping the x on top makes it easy for me. So I know that this 12 is related to this 9, right? When I turn the triangle upside down, I could see that they're in the same place. So 12/9 is equal to x/12. Once I get the proportion set up, all I have to do is go ahead and solve that. I simplified 12/9 to 4/3. 12 times 4/3, I can determine that x equals 16. So we've done this before. We reviewed it yesterday. If you're still having trouble with that, make sure you just take a little extra time today in the class meeting or send a message to a Google Meet or something so you can get help with it if you need it. Okay. But our essential question is, how can you use angles to tell whether triangles are similar? We spent a lot of time using similar triangles, but in order to do this, we first have to know that they are similar. Everything we've been doing in chapter 3 has been about angles. Can I use angles to tell whether or not triangles are similar? Well, as it turns out, it's actually pretty easy to do that. And it relies on the fact that we know that every triangle has an interior sum, a sum of interior angles equal to 180. So a triangle will be similar to another triangle if all 3 angle measures are the same. So if I have 3 angle measures in this triangle, and those 3 angles are the same as the 3 angle measures in this one, right? 65, 95, 20. 65, 95, 20, right? The 3 numbers are the same. So there's a 65-degree angle, a 65-degree angle, a 95-degree angle, a 95-degree angle, a 20. It doesn't matter how long the sides are. if those angles are the same, the two triangles will be similar. But as it turns out, it's not even that hard. I don't need all three. Because of that 180 degrees, I actually only need to show that two. I only need to show that two angles are similar in order to show that the triangles are congruent. If two angles are similar, then all three angles, the third angle has to be, right? But if two angles are similar, then the triangles are similar. So in order to use angles to show that triangles are similar, I just have to show that two angles are the same in the two triangles. So let's look at an example. Okay. Here I have a triangle. I have two triangles, these two pink ones, and I want to say, are they the same? Well, my key idea says, well, if there's two pairs of angles that match, then they're going to be similar. Okay, well, here I see a 75, and here I see a 75. So looking at the two triangles, I found one pair of angles that's the same, 75 degrees. Okay, well, here I see a 50, and here I see a 50. So I now have two pairs of angles that are the same. These triangles must be similar. Yes, they are similar. Okay? I don't have to do anything else. As it turns out, x is going to equal y, but I don't actually have to show that. As soon as I've shown that two pairs of angles, the 50 and the 75, are the same, then yes, these triangles are similar. So for the pink ones, it was really very easy. Let's go ahead and look at these orange triangles. Starts off pretty well. I got a 63, and a 63. So I have one pair of angles already. But then I look, I have an unknown, and I have a 54. Okay, I have an unknown. They might be the same, but I don't know that. And here's a 63. I do know that these two aren't the same. So are these triangles similar? I need to have two pairs of angles that are the same. But I can go back and look at my 180 degrees rule. So in this bigger triangle, 54 plus 63 equals 117. And I know that this whole triangle has to add to 180. 180 minus 117 equals 63. So this x is 63. Now I have a 63 degree angle and a 63 degree angle. I have two pairs, the purple pair and the green pair, that match. So yes, these are similar. Do I know the measure of y? I actually do. Y is going to have to equal 54, right? The third angle also must be congruent. I don't have to solve for it though. As soon as I can show that I have two pairs, then yes, these triangles are congruent. So here's another pair of triangles. I'm going to go ahead and put these actually in a Google form and have you complete that today as part of our check-in. And it says, tell whether the triangles are similar. Well, how do I know if the triangles are similar? Well, the triangles will be similar if I have two pairs of congruent angles. Don't forget when you're doing the sheet to explain how you know. How do you know that there are two pairs of congruent angles? Also, don't forget that this symbol right here means that that's a 90 degree angle, right? Whenever you have that little red square, a little black square in an angle, it always just shows that it's 90 degrees. So tell me whether they're similar, right? That's a yes or no question. And then explain, how do you know? How do you know that they are similar? So we said that what we wanted to do today was use angles to say whether or not triangles were similar. In order to do that, if two pairs of angles are the same, then the triangles are similar. Okay, we got that. The other thing we want to do is use similar triangles to perform indirect measurement. So if we're looking at these, we can imagine that this line continues on forever. This line continues on forever. And what we have are, if these lines from the sun's rays are parallel, and they are, the sun's so far away that the sun pretty much hits parallel at any given latitude. So what can we use from all of our angle studies? If they're parallel, what do we know about this angle and this angle? Well, what we know is that they're corresponding angles. and corresponding angles are congruent. So this angle has to be the same as this angle. So now I have one angle pair that's the same, and here I have a right angle, and here I have a right angle. So I have two angle pairs that match. These two triangles, the one formed by the flagpole, the sun, and the shadow, and the one formed by the boy, the sun, and the shadow, are similar triangles. Once I know that they're similar, then I can go ahead and find an unknown measure using my similar triangle rules. Okay? So I know they're similar. Well, now I can compare them. So this length of this shadow is 36 feet. Well, 36 feet divided by 3 feet, right? I'm making a ratio of the length of this shadow to the length of this shadow. Has to be equal to the height of the flagpole as a ratio to the height of this boy. Right? They're similar triangles. I've proven that by my fact that there are two angle pairs. So then I can go ahead and use that to solve it. And if you went about solving this with a calculator or your skills, you would find that that flagpole is 60 feet tall. Okay? So we've reviewed similar triangles. We talked about how to use angles to show whether or not triangles are similar. And then we quickly talked again about indirect measurement. There are some indirect measurement problems in the homework today. So we've met our goals. We've talked about them. If you have questions, please make sure you take one of the opportunities to ask them so we can help you. And today there is a check-in in Google form and a big ideas assignment that I would like you to complete. I hope you all have a great weekend. I'll talk to you soon.